Alright, we're going to talk about nomenclature of hydrocarbons. So hydrocarbon nomenclature. In other words, the naming of hydrocarbons. Alright, some things to think about is, first of all, what is a hydrocarbon? Well, we're talking about stuff made out of hydrogens and carbons. And nomenclature, nom means name, so it's the naming system for hydrocarbons. Let's go ahead and start off with, there's essentially two main concepts. Those are the prefixes, which tell you the number of carbons in a particular compound, and then there's the suffix, which tells you about the bonding between carbons. Okay, so the prefix tells you the number of carbons, and the suffix tells you about the bonding between carbons. Possible prefixes are as follows. Meth tells you there's one carbon. Eth tells you there's two carbons. Prop, there are three. Bute, there are four. Pent, 5. Hex, 6. Hept, 7. Oct, 8. Non, 9. And actually I think it's nona, and deca is 10. So meth, eth, prop, bute, pent, hex, hept, oct, nona, and deca will all tell you how many carbons are in a particular hydrocarbon. The potential suffixes, there's only 3. And they go in alphabetical order: ane, ene, and yne. If it's ane, it's got a single bond. Ene is a double bond, and yne is a triple bond. So when you put these together, let me give you an example. Let's say I say ethene. Ethene is going to be a compound that consists of 2 carbons. The ene tells you that the bond between them is going to be double. But remember, hydrocarbons are made of H's and C's. In other words, we're looking at hydrogens and carbons, so we're missing hydrogens on this hydrocarbon. The one main principle we have to understand throughout this entire thing is carbon needs 4 bonds. Of course, it just has to to go with filling its valence electrons. It's in the 4th column, so it needs 4 additional electrons in order to have 8. But carbon always needs 4 bonds. So let's look at this particular carbon right here. It has 2 bonds, so it needs 2 more. So it currently has 2 bonds, but it needs 2 more. So what you do is you fill in hydrogen with every additional bond that it needs. And this would be ethene. Carbon double bonded to a carbon with 2 hydrogens in each one, because this one as well had a double bond here, and it needed 2 more to get 4. Alright, let's move on to another example. Let's say I wanted pentane. Now pentane is made out of 5 carbons. Pent was 5, so we're talking about something with 5 carbons, and those carbons are going to be single bonded. That's what the ane tells us. So essentially we just draw 5 carbons, 1, 2, 3, 4, 5, with a single bond between each one. And then we fill in the additional hydrogens. This one currently has 1, so it needs 3 more hydrogens to get 4. This one has 2, 1 here and 1 here, so it just needs 2 more. And that's the trend for the next couple of them. Always trying to get 4. And this would be pentane. Now where we run into a problem is if I want, like, pentane. I'm going to tell you what not to do. Don't do this. That is this. If we go to draw pentane, we should recognize pent means 5 carbons, and yne is telling you that they're triple bonded. But what you realize really quickly is you can't triple bond everything. Because if you do that, this carbon alone has 1, 2, 3, 4, 5, 6, and we only know it wants 4. So this is not the structure of pentane. Instead, when it's anything other than ane, what we have to do is specify the specific place where that bond is taking place. Let me give you an example. So pentane would have to be either 1 pentane, 2 pentane, or actually that's all you could do. And let me tell you why. So 1 pentane. Here's how this would look. First we draw 5 carbons, and then we number the carbons. 1, 2, 3, 4, 5. Now it says 1 pentane, telling you that on that first carbon, that's where the triple bond's going to be, and all the rest will be single. So this one told you that on the first carbon, that's where we're going to put the triple bond. Now we fill in with hydrogens. This one would have 1. This one would have none. It already has 1, 2, 3 here and 1 here. This one would have 2 hydrogens. This one would have 2 hydrogens. And this one would have 1, 2, 3 hydrogens. No, it doesn't matter how pretty the hydrogens look, at least for now. All right, let me give you another example. Let's say I wanted to draw 2 hexene. So we'd first have to pay attention to the fact that this tells you there's 6 carbons. This 2-ene tells you there will be a double bond on the second carbon. So let's go ahead and draw hexene. 1, 2, 3, 4, 5, 6. And we know if we label them, carbon 1, 2, 3, 4, 5, 6, that on this second carbon here, we're going to put a double bond, like that. And the rest are going to be singles. Now we fill it in with hydrogens. This one only needs 1 because it already has 3 bonds. Same with this one.